such as the Solana Tech Tijuana Hackathon, where his team won third place with a Web3 project focused on building using blockchain technology and the Solana cryptocurrency. He's passionate about learning new technologies that enable him to grow professionally as a software engineer. I give the floor to Jair Soto.
Oh. Hi, good morning, everyone. My name is Jair Soto, and I'm going to present the project for ITA Labs, which is leveraging generative adversarial networks for synthetic data generation applications in tabular data. Okay, so here's a quick outline that I'm going to present. It's a little introduction, the methodology, the experimentation, conclusion, and our references. Okay, so in the problem statement, we notice that the AI models needs some high quality datasets, but scarcity and class imbalance often limit their performance. And here is where the GANs can generate some synthetic data. We have an example for a tabular data here, but producing this tabular data remains some challenging. And its impact on model performance under limited or imbalanced data is not well understood. So basically, we noticed this problem and we decided to work on it. Okay, so here are the 4 datasets that we found that we can work on. The first one is the hair failure prediction dataset, which is the clinical for predicting hair failure outcomes. Okay, so the second one is the Spanish wine quality dataset, which is based on the physico-chemical measurements with quality ratings. The third one is red wine quality dataset, which is chemical attributes with quality labels. And the last one that we decided to use is PIMA Indians diabetes database, which is the health indicators for diabetes prediction. We decided to use these 4 datasets because of their real-world relevance, their diversity in feature types, and sustainability for benchmarking machine learning models. Okay, so this is a quick state of the art. So basically, there are some projects that we found that share some same goals as us. So basically, here are some of them around since 2020, and the 2025 here is our work. And okay, so passing to the next slide. Basically, this is a quick overview that what we are using or what we were using during the project. So basically, the GANs is just generate synthetic tabular data to augment training sets. The machine learning models, they use real and synthetic data for data classification and get the metrics or results. And the classifiers that we use were the XGBoost and the CATBoost. So basically, we use those classifiers to get the metrics, the results. And the GAN models that we use to generate the synthetic data were the couple of GANs and the CT-GAN synthesizers. So basically, those tools we used. Okay, so here is a quick workflow of how the project works. And okay, so to start, we have the 4 datasets that I already mentioned before, which are the hair failure, the red wine, Spanish wine, and the PIMA Indian diabetes. So they're just the datasets we use. We now having these 4 datasets, we use them to generate the synthetic data using the synthesizers generators that I already mentioned. So we basically give the datasets to the generators, and the generators give us the synthetic data based on the dataset that we gave them. So now having the synthetic data generated by these generators, we have the experiment configuration, which is the train plus the validation, which is the real data without any synthetic data. So the second one is the train plus the validation plus the couple again, which is the synthetic data. So this is the real data plus the synthetic data from the couple-again synthesizer. And the last one, the train plus the validation plus the Citedi-IPN data, which is the other classifier we use to synthesizer. I'm sorry, synthesizer to get the synthetic data. So basically, there are different data become from different synthesizers. And now having the configuration, we gave all the data to the classifiers to get the trainings and finally get the metrics or the results. Okay, so here's a quick overview of what we did. So basically, we designed the 4 experiments to validate machine learning performance using the real and again generated tabular data using this classification task and our datasets. We took some tasks, like similar tasks, but we didn't find the exact projects, like we just used similar projects for them. Okay, so here is the distributions that we used. Where we have the dataset, the technique we use, the task, the train, the value, and the test. So basically, we use the same number of synthetic training samples as the original data set is generated. So basically, the classifiers are trained with the original data, the original plus the couple-again data, and the original data plus the Citedi-IPN data. Okay, so now I'm going to present some of the results. Okay, so this is the result for the first dataset that we used, which is the hair failure prediction. And here we can see a lot of results here, and this bold result is the best one. And so we noticed that using the XGBoost classifier and the couple-again synthesizer to generate the synthetic data, we were able to improve the results compared to the real data. So basically, our project was able to get better results than the real data. So in this case, the synthetic data improved the results. Now we have the second dataset, which is the Spanish wine quality dataset. And here we can see that the best result was the real data. So basically, the synthetic data wasn't able to improve the results. So in this case, we have our project wasn't able to improve the results using some synthetic data. So basically, that's the result for this dataset. And in the third one, the red wine quality dataset, we noticed that using the XGBoost classifier and the Citedi-IPN synthesizer to generate the synthetic data got the best result. So in this case, this synthesizer of the synthetic data got a better result than the other synthesizer and the real data. And in the last one, we can see a different synthesizer of synthetic data, which is the couple-again, and we can see that in this case, the couple-again synthesizer got the better results for our project. Okay, so here we have the little comparative, the results of the state-of-the-art, some projects that I already mentioned. So we compare our best performing models with existing state-of-the-art approaches across multiple tabular datasets, and this highlights the effectiveness of using GAN-based synthetic data augmentation and Citedi-IPN and couple-again for improving classifier performance. So basically, these are our results, that sometimes using synthetic data can improve the results compared to the real data. So basically, in the conclusion, we evaluated GAN-based synthetic data for tabular classification across 4 datasets, and we have the conclusion that synthetic data improve performance in scarce imbalance settings up to plus 2%. So that's a great news. And we build automated workflows for reproducible data generation and model evaluation just to have a better results. And a little of our future work that we are planning to work on, test advanced generative models, diffusion and transformers, add some domain constraints for realistic synthetic data, and automate detection of when augmentation is beneficial. So expand to domains like finance, healthcare, and cybersecurity, and explore hybrid quantum classical models for data generation and classification.